All right. So it's our pleasure today to have with us Bill Peery for what the umpteenth time.
I don't know. I love coming and playing with your guys.
I bet you hold the record for the most times you've spoken.
Oh dear.
Yeah, you're a good friend at Eternal University.
We're glad.
Bill's been a good friend to listen for a long time, and you're lucky that he's come back here to talk to us again. And you should be his friend too, because he has jobs. And what do you guys want? Jobs.
And I want to hire your people.
That's right. A lot of Laterno people have worked for what used to be called Analab.
Yes.
Now it's SPL Labs.
Yes, sir.
So there's an extra L kind of in there, huh?
Yes, sir.
All right. So yeah, if you need a job after you graduate, Bill's the guy to talk to.
Absolutely.
So don't let this opportunity pass you up. Okay. Bill is an interesting guy because he's got lots of diverse experience. He's got a BA in biology, okay, along with a minor in chemistry from the University of Texas at Austin, way back when, before you guys were born. And the here, and it was. He graduated from college before you guys were born, right? So did I. To think of it. Oh no! What about you, Miller? I don't want to talk about it. I want to talk about it. All right, talk about it. And he also has a BS in computer science with a minor in math. Okay. And then he also has a master's of science in computer science and chemistry from the University of Texas at Tyler. Okay. So he has a biology background, a chemistry background, and a computer science background. And he'll explain to you why that's important, that all these things work together to do what he does. Okay. We're good. Yeah. He's been the technical manager at SPL Kilgore since it became SPL Kilgore.
Yes, sir.
But he's been at Analab for what?
40 years.
40 years. He's been at Analab for a long time. Analab is a really interesting place. It started out in this guy's garage and it became a huge company right out there by Kilgore. So if you don't know about Analab yet, you find out about it. Okay? So if you want to follow up with Bill on jobs or anything else, the thing to do is to join us for lunch after the seminar. We're going to be in the presidential cafe because Bill is important.
Thank you, sir.
But the presidential.
Oh, wow.
Yes.
Wow. Thank you, sir.
Thanks, Bill. You gave us clout.
Oh, wow.
Yeah. So come on out for lunch after the seminar. Yes. And Bill's local, so you can follow up with him even if you can't make it to lunch.
Yes.
We'll give you his contact information and all the rest. So don't panic if you can't make it to lunch. But if you can make it to lunch, yeah, please do. Let's give Bill a warm welcome here.
Thank you, Gary. So it's my privilege to be with y'all again. The last time I was with you several months ago, we talked about some chemistry, and I love chemistry, environmental chemistry. We talked a little bit about some compounds that will be regulated soon enough. But today I'm going to talk about some compounds that are on EPA's radar. These are the PFOS and PFOAs. Now, have y'all heard about them? Okay, so we've heard a little bit about these compounds. So what are some, these are halogenated organics. What are some other halogenated organics that y'all might be familiar with? PCBs. Okay, well, let's talk a little bit about PCBs. So you've got some PCBs. These are polychlorinated biphenyls. These things, there's 209 theoretically possible PCBs present in the world that you could have. And they're regulated in batches. And they're the aerochlor mixtures that go from 1242 all the way through 1260. Now, why is that of concern to me? Because I was raised on 10 to 12 parts per million PCB 1260. Anybody my age, y'all are too. And you think to yourself, well, what are these organochlorine molecules doing to us? Well, they might make you a chemist. So I do environmental chemistry because it bothers me that there are compounds that could affect our health that at the time occurred at ppm levels, parts per million, 10 to the minus 6. And it bothers me enough to where I need to come share with you some of the other compounds that are of concern that could potentially be problematic. Nobody knows. These are the PFOS, PFOA compounds. Um, well, Professor, it's not obeying me. Oh, that'll work.
Try it again now with your clicker.
Oh,
No.
we're good. Thank you, sir.
Yeah.
So remember I told you these are halogenated organics? So we see the PFOS compound. These are C8s, but they have fluoride in there. And unlike the PCBs that have chlorine, these have fluorine. And so the sulfonic acid tail there is interesting. The PFOA there is the octanoic acid that you're looking at. And that's interesting. These compounds are as ubiquitous as PCB 1260 was for me. This is your generation's PCBs. Now, when I say that, you think to yourself, well, how did I ever end up with 10 to 12 parts per million? Well, it was in my milk. The cow ate the grass where the transformer dropped transformer oil on the grass. And where did it end up? I like milk. Every morning at breakfast, right? Okay. So these compounds, what are these things? Well, where do they come from and why do we have them? And why is it of concern to your generation? Well, so they're everywhere. We use them for everything. Have you heard of Teflon? So I remember coated skillet, right? Making eggs, scrape off some of the Teflon, right? Well, they're in fire phones. Why? They put out the fire. Good stuff. They are, you know, ladies in your mind. Right? Why? Make it pretty. Cleaning products, nail polish. I've never forgotten it. My son and I were playing with my wife's fingernail polish. He decided to paint my toe. And of course, I forgot about it. Went to the doctor, and the doctor was interested. So that stuff contains these PFOAs and PFOSs, right? They contain these compounds. Um, Dental floss, don't know why I'm worried about PFOAs. All your waterproof clothing, you know. Of course, pesticides. How about water-resistant repellents on coats and things, right? Clothes. Everywhere. So EPA decided, well, you know, if it's everywhere, and we have good experience, we mentioned PCBs, that if it's out there, it's in there. So UCMR5 is worried about drinking water. UCMR5 is unregulated compounds. EPA doesn't know if they're going to regulate it, but they're going to do some studies to figure out if they need to. What do you think is going to be the deciding factor of if they need to? Your drinking water coming out your tap is positive for these constituents of concern, these organohalides that are potentially problematic. We don't know yet. We haven't had the data to prove that it's a problem. So what are some of the health effects that doctors and such are worried about? Well, the first occurs to me might be some cholesterol levels that could potentially affect your blood pressure. Well, of course, you turn 60, you'll be taking some blood pressure medication, so what's it up? Who cares, right? You're going to take it anyway. Well, maybe this elevates it. Maybe you get sick more often. Maybe you have an increased risk of cancers. Now, that's not a pleasant plan. Why could it be a potential carcinogen? It's a halogenated organic. How many compounds do we know are halogenated organics that are potentially carcinogenic? A bucket load. I might start drawing some structures, so I won't. The increased risk of thyroid disease, some weight deficient infants, none of this is good news. We need to study it to decide if these PFAS, and more specifically, which PFAS compounds might be problematic. So it's hard to analyze these compounds. I was sharing with one of your professors just a few minutes ago. It cost me $500,000 to buy the box to run it on. These are some very sophisticated toys with very in-depth, hard to read, hard to understand, even for me. Telling you, these are some serious methodologies. Nobody's piddling here. There's a reason that I, along with 49 other colleagues, are accredited to run this stuff. That's it. Little old Kilgore, Texas has a lab accredited by EPA to run these. That's cool, right? So we've got some problems complying with this. But EPA's not kidding. They're not playing. They're very, very, very serious. I have all kinds of restrictions on me. The client has all kinds of restrictions on their samples. You get to resample if you don't hold your pen right. And it better be a ballpoint pen, because if you use your Sharpie brand felt tip marker, it's in it. So EPA decided to regulate anybody that's got more than 10,000 hookups, connections, whatever they call them, people. And if you've got even 3,000 people, you get to play too. And lithium. Lithium by UCMR5 was tossed in there because the pharmaceutical people use it. What do you think pharmaceutical people do with lithium? Folks that are depressed, right? They give them lithium. But guess where it ends up with? Same place our PFAS does. 25 PFAS compounds by EPA. Oh, I'm quoting right here. 533. 4 PFAS compounds by 537. And depending upon your water source, well, river, lake, and there they all are. Now this will send an organic chemist straight to nirvana. It's fabulous. So we have all of these beautiful compounds, but notice their characteristics. You see, look at, feel them. You know, we talked about some sulfonic acids. We talked about the fluorines, perfluoro, heptane, sulfonic acid. All of these compounds are very much related, and they're present. I analyze this stuff for a living, and I'll tell you, based upon EPA's UCMR5, that we see a lot of these compounds in your drinking water. Right now, this morning, I verified a set of them. So, what are we finding? PFAS, PFOA. You know, if you look at your water supplies that they tested, about, they claim 9.4%. It's going to vary by your region, but I'm telling you, there is not a day go by that I don't verify a set of these things that glow in the dark. Not really. They're high in these compounds. And so you look at the data there and you can say, well, okay, so about 10% of them, 9.4% of them to be precise so far based on our preliminary data, indicates that indeed this is a national crisis. This is every bit as problematic for us as the PCBs for me and your professors. Okay. So regulations are coming, and how do you sample this stuff though? I'm looking at very low concentrations. What do you think the MCL is? The the reporting limit I do for some of these PFAS compounds. Remember, I was talking about PCBs at parts per million levels? 10.6. These are not parts per billion. 10 to the minus ninth. What are they? 3 orders of magnitude more. Parts per, starts with a T. Yeah, parts per trillion, 10 to the minus 12th. That's my reporting limit for these compounds. I've got some cool toys. But the point of the matter is that you can't just go out to the field and scoop you a dipper or some water. Why? Because you glow in the dark relative to the limits I'm testing for. You'll contaminate the sample. So clean hands is a sampling technique where multiple people are involved. You can't just go into the field and collect this stuff. You daggone well better have a buddy who helps you with the clean hands. And you can Google that, okay? Google up clean hand sampling techniques. You've got some gloves. Why am I worried about clothes? So recently we were purchased by a corporation. I've never worked for a corporation. I've always worked for mom and pop. Well, corporations have safety directors. Safety directors decide what clothes are going to be to test your samples. Now, I had to explain to Mr. Safety Director that his 3% fireproof lab jacket was not going to work in my laboratory. Why? It's fireproof. If it's fireproof, guess what's in it? PFOS. Guess what I test for? Percent level, 10 to the minus 2. What's my detection levels for PFOS? 10 to the minus 12th. Orders and orders and orders of magnitude difference. Oops. So I had to explain to him, no. Personal care products, waterproof materials. Oh my gosh. You know, don't go in there with your hand lotion sampling our stuff. Why? It's gonna be positive. Please. I use Sharpie brand felt tippers all day. Don't take them to this field sampling activity. Why? It's got PFOS. You need real ice. Please don't use blue ice for anything in the environmental world. It doesn't get cold enough. And oh, by the way, Ziploc everything. The bottles that we collect are dictated by the methodologies. You're going to use plastic. Now, for organics, that blew my mind. Why am I using plastic instead of glass? Why? Those little critters are going to stick to the glass at the levels I'm playing with. So I have to use plastic. In this case, polypropylene. I've got some preservatives. For most of them, under the 533 protocol, we need to use an ammonium acetate preserved bottle. And notice that I've got a field blank that has to be collected at every location. Why? Because I want to know if the field samplers contributed to the PFAS concentrations that I'm finding in their samples. And then there's another one for 537. It's using Trisma. I don't remember if I was brave enough to include this slide. So, where's my... Now I'm starting to sing. So we've got some pKa's. And what I'm saying is that at 8.1 is where Trisma lives. So that particular buffer is going to put the pH at 8.1. And that's going to allow me the opportunity then to preserve those compounds in accord with EPA mandates. And so over here, I'm frying stuff. Over here, I'm frying stuff, but I got a weak acid cooking off up over there. And so life is good. A trip blank is exactly what you think. I sent it in the cooler. A field blank is different. I put it in the field. Clothes, my gloves, just the environment causing me grief. Is that what causes these compounds? Remember, they're everywhere. I've got a field blank that I poured, but then also have something called an equipment blank. Well, sometimes I go to wells where I have to sample it with a hand baler. Well, my equipment blank, I'm going to fill it with distilled water, and I'm going to pour it into these preserved bottles. Why? Because I want to know if there's anything in the field that is contributing to the positives that we have. And then I need to do some sort of a replicate measure. I should do it every 10 samples, or at least once per location. And I need to know what my precision is for these compounds. So the idea is, can I get the same answer twice? Translation, is it real? Well, so if you think about it, all the way back to my instrument blank in the lab, how do I know my instrument didn't contribute to the positive results I'm going to report for that client? Remember, EPA is going to regulate this stuff, and they're going to regulate it out the wazoo. You're going to be spending millions of your taxpayer dollars, hopefully for analysis. So if you include an instrument blank to a method blank, what's a method blank? Can I take a sample of distilled pure water that I know does not contain these constituents of concern? Can I guarantee that I can put it through my lab process? We talked about the instrument could contribute. We talked about the extraction process, the sample preparation could contribute. The trip itself could cause you some problems. Well, the field that you selected, got that from, could cause you some trouble. And then, of course, we talked about the equipment blank. And so you can see these cascading ways that we're demonstrating that our error rate is very low to non-existent, and we know exactly where it occurs. And so you get to do this because EPA said so. That's why I work. Whether it's your drinking water regulations under 40 CFR 141, your wastewater regulations under 40 CFR 136, whether it's any of these UCMR 5 requirements that EPA is mandating now, you're going to have regulations that control every aspect of it. You see, this isn't research chemistry. I've got a method. I will follow that method. Period. You would be shocked at how hard it is to implement this in the field, particularly for people that don't work for us and have been trained to do it. They've been collecting samples forever, but to do this is a different level. Oh, these are some different EPA methods. I didn't talk to you about the 1633 yet. This is the wastewater component and solid waste for sludges that I almost have online. I verified some results this morning that indicates that things are going well. I'm not running 1621. I don't believe in screening procedures. You either do it with full QC or you don't know what you have. Now, I mentioned some units. Talk about milligrams per liter or parts per million. We can talk about parts per billion. We can talk about parts per trillion. I don't analyze stuff at parts per quadrillion yet, but I look forward to doing that before I retire. So that's my hope. To close this thing out, just sharing a few of these things. Think of a barrel. I'm going to drop, it says 3 drops. I didn't validate this calculation, but I believe it. It's about right. We've got a tanker truck. And I'm going to drop a few drops, in this case, 1, to get a parts per billion. But look at my parts per trillion. That's the Rose Bowl, I'm told. Fill it up with water and drop 10 drops in it and find it. I do it all day. I also spend a ton of money on some toys. Makes me happy. That's a box that runs stuff. The key is that the front end of this thing is an HPLC, high pressure liquid chromatography. The notion is that these compounds are sufficiently polar due to the halogenated atoms that are on it, that you've got to use HPLC. You can't put it into a GLC, a gas liquid chromatograph, and get anything out the back end of the column. You have to use HPLC liquid chromatography. And then this is my sales pitch. We can do all that. We'll even give you the bottles, properly preserved, guaranteed to be PFAS free. And what does all this mean to you? 10 to the minus 12 doesn't sound like much, right? Back in my day, 10 to 12 ppm didn't sound like much PCB 1260, right? So we're in a new era. I can look at parts per trillion and I can find it in your drinking water. I can find it in your healthcare products. I can find it in your eye makeup and fingernail polish and dental floss. It's everywhere. What do you want to bet? It's in all of us too. And what does that do to us? Don't know. So I'll take questions, guys. Yes.
It's easy to get contamination from contact with all these consumer products. Why are we worried about the source for water if we get it every time we just rub up against our clothing? Why would we be concerned about those much lower sources?
So that's a fair question. I mean, my point is that I told you about a lab coat that's fire retardant in my very lab that is at least 3% PFAS. 3%.
Yeah.
I'm looking at parts per trillion in your water. Why are we all worked out about it? Because the suspicion, and this has not been proved, but the suspicion is that even at these low concentrations, you can have significant endocrine disruption. And when you give your baby a bottle of water, through time, the notion is it accumulates, bioaccumulates. And so as a consequence, it could have some profound health effects, reproductive ramifications at some other point in time. And so is it going to get there through skin absorption? Maybe. Is it going to get into our bodies if I drink it? Darn right. Is it going to be retained? Studies seem to indicate so. Other questions? Sir.
Installed for 250 milliliter polypropylene bottles.
So that's a really good question. The idea is that we send them out to the field, and if they don't come back, I charge them for them. So that happens to that piece of it. The other piece is well, what do I do with it once I get the samples back. Now, the idea is that PFOAs, they're not going to stick to the plastic. That's why we bought plastic instead of glass. So I rinse them out and toss them. They should be clean. I hadn't validated that, but that's the laboratory practice.
So they're not recycled or?
I'm afraid to recycle stuff like that. I'm terrified of recycling any of my bottles.
Goes to landfill someplace.
Yeah. So I'm not thrilled with that solution as an environmentalist, but I've got so much liability that I can't take the risk of doing anything other than that. Yes, sir. Parts per trillion, 10 to the minus 12th. Well, nobody knows, but my suspicion is that it accumulates through time. And the longer you're retaining it, the more mischief it causes. Okay? That's the assumption. Is it true? I haven't proved it, but I hope to do a lot more testing in the process. Other questions? This is good. Y'all are a smart group. Sir.
You mentioned that you can't use GC. Why?
So you can't use GC because your detections are insufficient. You can't get low enough. So it does me no good to say that with a GC, I can do, well, with a traditional GC, I can generally do, suppose that I had something like an electron capture detector. Now an ECD is going to be very, very sensitive as GCs go, right? So an electron capture detector is going to be able to nail down a decent curve at the part per billion level, 10 to the minus 9th. You still got 3 orders of magnitude to go before you can do anything useful with these compounds. Yes, 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 yes. And so it's a beautiful machine. It makes me happy. Sir? Yeah, it's on. There's a. So group 7, periodic chart, starts with fluoride, goes to chloride, goes to bromide. I generally don't analyze the last 3. EPA hasn't written any regulations on it, but I analyze a ton of those first 3 groups in that group 7. Sir?
What was it that originally scored?
So there's research that goes on in EPA's labs. They have regional labs, and they do stuff. They do crazy stuff. And it usually takes about 2 decades before it filters to people like me. And so eventually they'll get there, but for at least 20 years, the EPA has conducted research all over the country looking for weird stuff. What's here? And the scientists that work there, like to do novel tests, and they come up with these methods, and they're the people that wrote the methods for people like me to implement. Other questions, guys? This is cool. Oh, we got time. I left lots of time to play. Yes, ma'am. Yes, yes, yes. Okay. Okay. So generally we use D. And so the notion is these are deuterated analogs of constituents of concern. It's a mouthful. Let me break that down. I got me a rose and I paint it gold. Now I got me a gold rose. I can tell the difference between that and the red rose. Now I have an analog of my rows that I can use to monitor recovery in my extraction efficiency. In my analytical system, I can monitor effects that could potentially be problematic. Remember, I'm pushing this through a column. It's going through a lot of processes. I need to know what kind of recovery I get. And so let me take it outside the realm of PFOAs and do something a little more simple. So I use a deuterated analog of toluene when I analyze a BTEX result, benzene, toluene, ethylbenzene, xylene suite. Now, these are aromatic hydrocarbons that I can use to determine, okay, I've analyzed this thing for toluene, but how good is my recovery? Because I'm using mass spectrometry, I can use D instead of H and buy a toluene standard that instead of having H going around it, it has D's going around it. Okay? I love this stuff. Other questions? So when are y'all gonna come apply? Oh, yeah. So we go and we get a set of samples, or they ship a set of samples to us, or they deliver a set of samples to us. It's all these bottles, 50 of them come in. Boom. Well, you just can't put them anywhere. They have to be stored in very, very, very careful conditions. In this case, it's a special cooler that we use. Think of a refrigerator, but it's not your mama's refrigerator. This one we're going to hold temperature. Now, we hold the temperature there, but we can't just stick it in any building, can we? Because why? My lab techs wear 3% PFOAs, right? So I just can't leave it in that building. Don't hop off and jump in my bottle. Oops. Now everybody's positive. Well, Machiavelli would say that's more work for me, but nonetheless, the point is that you have to keep it contaminant free. How do I know that I do that? Remember my field blanks? Remember my lab blanks? Remember my instrument blanks? Why do you think I'm paranoid? Why do you think EPA is paranoid? Because it's so easy to have a false positive, particularly when you're dealing with things that are parts per trillion. Okay? So you have to be careful. So then they're stored right, and then we have to extract constituents of concern. Now, in order to do that, I need to concentrate the constituents of concern. And so I've got this little cartridge that allows me to stick a PFOAs on the top of it, flush through 250 mils of sample, and then elute that and concentrate it down to 1 mil. Now, I've got a 250-fold concentration on this sample, don't I? 250 mils to 1. Now, what does that enable me to do? It enables me to reach the method detection limits that I through sample preparation. Thoughts? Ooh, this is cool. I think they're going to sign up, guys. Other questions? But anyway, that's what we do. Oh, and then we get to run it on the toy. I mean, my work product, my instrument. That's what I tell my investors these days. It's a very important tool. It's my toy. Don't tell anybody. Other thoughts? Painted, did I cover what I want to, or do I want to? I can draw pictures. Thank you, guys.
Otherwise,
Yeah, thank you. I entertain myself. I love playing with your students.